Welcome back to Meteorology Matters. We're diving into some pretty cool weather and earth science today. If you like what you hear, I encourage you to follow meteorologist Rob Jones on Instagram, meteorologist on TikTok, TV meteorologist, and on YouTube, follow Rob Jones Hurricane, where you can also find the Meteorology Matters playlist. All right, let's head north today. Up to Alaska. There's a volcano up there that's been making headlines, Mount Spurr.
Yeah, Mount Spurr. It's a stratovolcano about 75 miles west of Anchorage. It's definitely caught the attention of scientists lately.
So when we hear volcanic unrest, it makes you think eruption, right? But what does that actually mean?
Well, it doesn't always mean an eruption is about to happen, but it does mean something's changing. Imagine a pot of water on the stove, simmering. You see bubbles, steam, maybe the water level even changes a little. Those are signs of activity. Volcanic unrest is similar. We might see more earthquakes, changes in the ground, even the gases coming out change.
It's like the volcano sending signals. So what kind of signals are we seeing at Mount Spurr?
One of the biggest is the earthquakes. Way more earthquakes. We used to see like 30 a week. Now it's over 125. Since April last year, they've recorded over 2,700 earthquakes there.
Wow. Are we talking like major earthquakes?
Not really. Most of them are small. The strongest one was 2.9. But it's the pattern, the frequency, that tells us something's happening, like magma moving underground. And that gets volcanologists' attention.
So it's not just about how strong they are, it's what they tell us.
Right.
Okay, what about ground deformation? What is that exactly?
It means the shape of the volcano is changing, even tiny changes. We can measure that. It means pressure's building up as magma moves up, like inflating a balloon. It changes shape as you put more air in.
So the volcano's kind of inflating.
Yeah.
And that gives clues about what's happening below. And then there's fumaroles.
Yeah, fumaroles are basically vents, openings where volcanic gases escape, like little windows into what's happening inside the volcano. We can look at the temperature, what the gases are made of, how much is coming out. Tells us about the magma below.
Taking the volcano's temperature, checking his breath.
Yeah. And you know what's really interesting? There's this new lake formed in the crater last summer. It's mostly frozen now, but there's this incredible turquoise water visible in places.
Turquoise. That's not what you expect in a volcano.
Right. It's from dissolved minerals, volcanic gases mixing with the water. Actually, the exact shade of turquoise can tell us about the gases and the water temperature.
Wow, even the color of the water tells a story. And then there's the steam rising from the frozen lake. Those plumes of vapor from the fumaroles. It's a pretty striking image.
It is. Ice and steam against this massive volcano.
Beautiful and kind of scary at the same time. Reminds you of all that power underneath.
Exactly. Which leads to the big question. What if Mount Spurr erupts? What would that look like?
Yeah, what are the hazards? And this isn't just some remote volcano. This is pretty close to Anchorage, a big city.
Right, and that's what makes it concerning. One of the biggest dangers with stratovolcanoes like Mount Spurr is something called pyroclastic flows.
Pyroclastic flows, I've heard that term. What are they exactly?
Imagine a super hot avalanche. Gas, rock fragments, ash, all rushing down the volcano super fast, like over 200 miles per hour.
200 miles per hour. And I'm guessing it's hot.
Yeah, definitely. Hundreds of degrees Celsius. Extremely dangerous.
Sounds terrifying, like a volcanic hurricane of ash and debris.
Powerful force of nature. Then there are lahars, too.
Lahars? What are those?
They're like volcanic mudflows. Hot volcanic debris mixes with water, usually from melted snow and ice. These mudflows can travel for miles, picking up speed and everything in their path. They can bury entire communities.
So it's not just the eruption itself, it's what comes after. And ash clouds, too, right?
Yeah, we all know those images of massive ash clouds during eruptions.
Those disrupt air travel for sure. What other impacts can they have?
They can be really bad for your health, especially if you have breathing problems. The ash particles get into your lungs. And depending on how big the cloud is and where it goes, it can affect agriculture, water supplies, even damage buildings and roads.
So everyday life gets disrupted, even if you're not right next to the volcano.
Exactly. The eruption back in 1992, even though Anchorage is pretty far from Mount Spurr, there were still big impacts. The airport had to shut down, ash everywhere. It's a good reminder of what can happen.
Yeah, good reminder. The 1992 eruption gives us an idea of what to expect if it happens again.
Right, and it shows that it's not just the immediate danger, there's a ripple effect.
This is giving me a lot to think about. We've talked about the warning signs, the dangers, even a bit of Mount Spurr's history. I bet our listeners are wondering, how likely is it to erupt, and what are people doing to get ready? We'll get into that right after this.
So we've painted a pretty intense picture with those hazards, but an eruption isn't a sure thing.
Right. It's not a guarantee, but those signs are definitely concerning.
They are. But the volcanoes, they can be unpredictable. We've seen this kind of unrest before at Mount Spurr and nothing happened. Back in the early 2000s, there were a lot more earthquakes than usual. Everyone was worried. But it just died down. No eruption.
So how do scientists figure out how likely an eruption is? Is it like, I don't know, predicting the stock market? Or are there things they can actually look at?
It's complicated. Volcanologists use a lot of different information, what's happening right now, the monitoring data, and then what they know about how the volcano has acted in the past. They look at the seismic waves, the ground deformation, the gases, even the heat coming from the volcano. All those pieces together help them understand what's going on inside.
Like a detective putting together clues.
Yeah, exactly. They've got some pretty amazing tools, too, instruments and computer models. But volcanoes, they have a mind of their own. You can't always predict what they'll do.
So even with all the technology, we can't say for sure if or when it will erupt.
No, nature's a powerful thing. We don't always understand it completely. But that doesn't mean we can't do anything. We might not know exactly when, but we've gotten a lot better at forecasting volcanic hazards.
Okay, that's good to hear. So if we can't predict exactly when, how do we get ready for an eruption?
That's where monitoring and preparing ahead of time come in. There are organizations like the Alaska Volcano Observatory. They're really important.
Tell me more about the Alaska Volcano Observatory. What do they do?
They're like the watchdogs, keeping an eye on all the volcanoes in Alaska. They have seismic stations all over. They fly over the volcanoes to measure the gases coming out. They even use satellites to see if anything's changing. All that information goes to emergency management, people who make decisions about flights, and, of course, to the public.
So everyone's working together.
Yep. You've got the U.S. Geological Survey, the University of Alaska Fairbanks, the state of Alaska. They all work together to keep people safe.
That's impressive.
Yeah.
So monitoring is key. But what about actually protecting people if an eruption does happen?
That depends on what kind of eruption it is, how big it is. If it's small, maybe just some ash. The main thing is to get people who live close to the volcano out of there and make sure planes don't fly through the ash.
And if it's a big one?
Then you're talking about evacuating a lot more people. Ash could cover huge areas. Transportation would be messed up. Power could go out. And remember, ash can be dangerous to breathe. They have to plan for all of that.
Wow, so many different things to consider.
And it's not just up to the government. Everyone who lives in a place like this or even visits needs to be ready. Have a plan, a kit with emergency supplies, and pay attention to the warnings from scientists and officials.
We all have a part to play. Being prepared can really make a difference.
Absolutely, especially with Mount Spurr. Being prepared is so important. So let's look at what scientists are seeing right now, how they're monitoring it, and what they think the risk is.
Okay, let's get into the details. What's the latest on Mount Spurr?
The most important thing is the seismic network. 11 seismic stations all around the mountain. They're constantly listening for earthquakes.
11 stations? That seems like a lot.
Yeah, pretty impressive. And they do flights over the volcano, too, measure the gases coming out. Any big changes there could mean the pressure inside the volcano is changing, which could mean it's getting ready to erupt.
Like checking the volcano's blood pressure.
Huh. That's a good way to think about it. And they even go out there and shovel snow off the instruments, make sure they're working right. It's amazing how dedicated they are.
Wow. So what's the verdict with all this data? How worried are scientists about an eruption soon?
Well, that's the question, isn't it? The earthquakes are definitely a red flag. But it doesn't always mean an eruption is coming. The scientists are looking at all the data, trying to find any clues about what's going to happen.
So we wait and see.
We wait, but we watch. The scientists are always working, updating their models, figuring out the risks, and they're sharing what they know so that people can be ready. It's a combination of incredible science and people working together to keep everyone safe.
Well, we've talked about a lot. How volcanoes work, how they're monitored, and what's happening at Mount Spurr. But before we finish, I want to ask our listeners something.
Give them something to think about.
Exactly. We've talked about how an eruption could affect air travel, people's lives, the economy. What do you think should be done to get ready for an eruption? We'll be right back with some final thoughts. And we're back with Meteorology Matters.
Back for the final look at Mount Spurr.
We've covered a lot, from those signs of unrest to the possible dangers, and all the work being done to keep an eye on things and be prepared.
Yeah, it's a fascinating look into how volcanoes work, isn't it? And it reminds us that this planet is always changing, forces we can't control.
That's for sure, but we can try to understand them, right? So we can make smart choices and be safer.
Exactly. So as we wrap up our Mount Spurr deep dive, what are the big takeaways for our listeners? What's important to remember?
Good question.
Well, first of all, Mount Spurr IS showing signs of unrest. The earthquakes, that's a big clue that something's happening underground. But, like we've been saying, it doesn't necessarily mean an eruption is going to happen right away.
Yeah, it's like that pot on the stove again. Simmering away. Might boil over, might not. How do you know?
Huh, exactly. That's why the monitoring, the research, it's so important. The more we learn, the better we can understand what Mount Spurr is doing and what it might do next.
Which brings us to preparedness. Whether it erupts tomorrow or years from now, being ready is crucial.
Absolutely. And it's not just the government's job. Everyone has a role to play. Individuals, families, communities. Have a plan, have an emergency kit. Know what the scientists and officials are saying. Pay attention to warnings.
Hope for the best, prepare for the worst, right? Especially with volcanoes. A little preparation makes a big difference.
Couldn't agree more. The more we understand about volcanoes and what they can do, the better we can handle it when something happens.
Well said. Big thanks to our expert today for all this great information.
My pleasure. Volcanoes are amazing, powerful things. Always happy to talk about them.
And to our listeners, thanks for joining us for Meteorology Matters. Hope you enjoyed it.
Stay curious, stay informed, and stay prepared.
We'll see you next time. Keep exploring our amazing planet.